The goal of the board is to have an image processing platform, a high-end image processing platform that gives the possibility to deliver innovative algorithms, innovative applications. And the challenge in this project really was so high that we appreciate the support from mentor guys who helped us several times.
Most important driver for designing this board was that we need a high-speed calculating board for image processing. That was the reason for the development of this board.
What is impressive is that there's a huge area for power supply. Just to give you an impression, we have at 1.2 volts we have 100 amps, and then we have additional power supplies also with dozens of amps, and that's a real challenge to distribute the power across the PCB and make sure the power supplies are stable under any conditions. The second characteristic, in fact, is that it's a very dense design with thousands and thousands of high-speed signals, differential match lengths, every constraint you can have in PCB design. And concerning the PCB itself, it's an 18-layer PCB, which is very unusual if you have to do it within 1.6 millimeters. We have 10 power layers, which most of them being split power planes. It is difficult to get enough copper into the PCB to carry the currents, and then above all this you have power transients in the tens of amps, which causes almost unpredictable effects. From my view as a project manager, there were in fact two issues that routinely came up. One is the power issue, the other is signal integrity and timing issues. And from a global point of view, from a bird view, I would say the strange thing is that today in the PCB, two extremes come together. So the classical separation of energy and information is not valid anymore. You have energy and information very close together.
We use hyperlinks for simulation, and for this it was a good tool. You can work very fast with it and get very good results.
What was very good, was very well achieved, is that we did not have any signal integrity issues on the board. We did simulate our high-speed signals, and everything turned out fine as planned, which is good luck and good work. Basically, the customer was quite impressed that we did a prototype within 6 months from the start. The thing we are proud of at the end of this project is that we are running extremely intensive and aggressive tests, and this board is rock solid. And that's a little bit unusual, knowing that you have plenty of jitter and power issues to cope with. What impressed me about Hyperlinks, what actually was unexpected, is that Hyperlinks was able to load the whole database of this PCB, because it's a huge and complex PCB, and there were other tools from other vendors which broke down, and we could do the signal integrity simulations with the real layouted design without problems. I liked that very much.